Hello everyone. Hope all of you are extremely good and healthy. So first I wanna apologize a little for sending this pre-recorded video because I probably will be traveling during the meeting. So let's start. As you guys know, my project was to integrate the team library and the team models with OpenVINO and to create a clear guidance and clear step tutorial how to use OpenVINO enhancements in the infant stage of team models and how to utilize those. So for those who don't remember, let me just give a little overview of the whole scenario. Team is a library in the PyTorch ecosystem that hosts more than 1100 pre-trained computer vision models. This library is pretty important and pretty influential in the PyTorch community because we have a large number of pre-trained models, which is very useful, and we can load the models very easily and use those for our purpose. So what happened is, just as our project was confirmed, GSO project was confirmed, Team has been integrated with the Hugging Face ecosystem. So now it's under the Hugging Face ecosystem, and then went to think that we already have a project that's the integration between any Hugging Face operation and OpenVINO's operations, that is Optimum Intel Library, which is maintained under the banner of Hugging Face also. So we decided why not make our contributions there, and the Optimum Intel maintainers also agreed to that. So let's discuss a little about the structure of Optimum Intel. Optimum Intel maintains a similar API interface to Transformers Auto Model for different tasks. So as we know, there are different model pipelines for auto model for task text classification, for token classification, for question answering, and for image classification, etc. So Optimum Intel also maintains a similar API interface, but those classes start with the OV model for different tasks. So here you can see some examples. For text classification, we have OV model for sequence classification, then for token classification, image classification, feature extraction, etc. So then we got to see that most of the team models are image classification models, and then I, my mentors, and everyone together decided that let's extend the functionality of the OV model for image classification so that it can seamlessly load team models from the Hugging Face Hub and then operate with that. So this was a discussion in the issues of the Optimizer library, and we came to a final goal how we want our models to work. So the final expectation was to load using the from pre-trained method like any other transformer or Hugging Face Hub models we load to this OV model for image classification class. The previously before my PR, the problem was if we went to load any model through like this, we raised a number of errors and the process wasn't successful. This is because team library and Hugging Face transformers models evolved very differently, and so there are some inherent difference between their structures. So the strategy I took was to create a wrapper around the team models that handles all the discrepancy between the transformers models. And so what OV model for image classification will get is a uh, is something that behaves exactly like any other transformers model, but which internally contains a team model. So once again, is the final goal that we have worked for, this interface. We will discuss about this at the later stage of this presentation. So now let's talk a little about the what are the abstractions that the wrapper has to handle. So every uh, in the team library, the team models are standalone models and they don't have any other strings attached. But in the Hugging Face library, for every model, we always have to have one model object, one config object, and depending on the domain of task, we also need some feature preprocessor. Every model needs to inherit from pre-trained model class, and every config needs to inherit from the pre-trained config class, and the preprocessors also have their own expected structures. So this is the PR I have finally opened. As you can see, this have been merged after a lot of discussions and code reformatting. So let's discuss in a little more depth about my contributions. So the first thing I did was, as we need a config object that operates similar to the transformers library's config objects, I created it in config, but there are some inherent differences between the expected config structure from the transformers library or Hugging Face world and the team models. So I loaded the team configs and then handled all those differences underlying inside the code, and then we returned a config that is pretty similar to any other transformers config object, and that is the task of the team config class. If we go to convert any PyTorch model to OpenVINO, we go through the ONNX transformation process. So we also needed another config for this uh, honest conversion. That is what we have used here. We have created here the team honest config. Then every team model has its expected input size, expected image distribution, and other things, all of which are mentioned in the config object, which is team config for now. So this team processor is another class, the feature extractor class that have implemented, specifically adapted from another image processor in the transformers repository, and that can take its values from the team config object and then convert preprocess the image just the way uh, it's expected for the team model. Then we had also to write some test cases to check or validate the functionalities we have added. So I have added two tests. One is as I've probably said previously, every OV model for image classification model has the ability to convert to load a model from transformers library, then convert it to OpenVINO format and save it locally, as well as load from that saved format and finally do inference. So this is the portion where I have checked if our newly added functionalities for team models, we are able to save the models and again load and inference. So you can see we are loading a team model through the OV model framework classification class. Then we are saving it in a temporary directory, and then we are also loading it from that directory, from the local directory, and finally doing an inference step to check if the model raises an error. And we see that the model performs as expected. Then the next issue was, what if the our wrapper is in any way degrading the model's output qualities of performance? So I have written another test that actually loads the model through the expected way to load team models, as well as loads a model with the OV model from image classification class, and we use an image output to both of those loaded models and compare the outputs, and this ensures that our the performance of our loaded or our converted and exported team models doesn't degrade at all from the team models that are loaded directly in the suggested way. Then this is the final summary of what I did. So to summarize in a sentence, Now, after this pair being merged, team models can directly be loaded and exported from the Hugging Face Hub through this OV model finished classification class. I have also introduced necessary config classes and image pre-processing classes, as well as have written some tests for that. And this is was actually my first experience for writing test cases for some uh, ongoing production level project. So this was really a great experience for me, a learning experience. And now this is after this pair merge, this is our expected usage pattern. Let me go through this. So here I'm importing the image preprocessor, team image processor that I have implemented. We are getting an image and we are processing that image through this team image processor class. Then we are loading a team model from through the OV model for image classification and passing the output of the model to the to our output of the preprocessor to our model and getting the output logics. So to summarize again, now team models can be seamlessly converted to the OpenVINO format. We can leverage OpenVINO's performance enhancement, and as now team models can easily be loaded as transformers or Hugging Face models, we can use various functionalities of Hugging Face, and that is something I might work on work in future. Every Hugging Face model currently, uh, most of the Hugging Face model currently supports some specific types of quantization that like 8-bit quantization and things we can explore if we can use also those with our OpenVINO IR formatting, as well as we have our own NNCF uh, model optimization project. So we there are some more aspects to explore through that project also. That if how to what extent we can extend our uh, things. So finally, I want to express my gratitude for this opportunity to work with OpenVINO and such amazing mentors as well as the contributors. And thanks to everyone who are connected with this OpenVINO's GSOC initiative, especially Alex and Luba, my mentors. Thank you, everyone. Have a great day.